When we talk about the EV revolution, our minds usually jump to these huge battery factories or those sleek, futuristic car designs. But what if I told you that deep inside the motor, there's a tiny, hidden component that's just as critical? It's a component at the center of a massive global power struggle, one that could really define the future of green energy. So let's get into it.
All right, so if it's not the battery, what could it possibly be? What's this secret ingredient that takes electricity and turns it into the raw force that spins the wheels? It's something you've probably held in your hand before, just, never on this kind of scale.
That's it, a simple, powerful magnet. But look, we are not talking about your average refrigerator magnets here. We're talking about supermagnets, literally the most powerful permanent magnets ever invented. And they are absolutely essential for the incredible efficiency and performance of pretty much every modern EV you see on the road today.
So, what is it that makes these magnets so incredibly special? Let's dive into the science behind the EV's secret ingredient. They're called NdFb magnets. That's short for neodymium, iron, and boron. They were first discovered back in the 80s, and they just pack an unbelievable magnetic punch for their size. And that's the key, right? It lets engineers design electric motors that are way smaller, much lighter, and far more efficient than anything that came before.
But, and this is a big but, there's a problem. Electric motors, especially the high-performance ones we want in EVs, get seriously hot. And for all their amazing strength, these NdFb magnets have an Achilles heel. Extreme heat can permanently destroy their magnetic power. A hot motor could literally bake the strength right out of its own magnets.
So that leads to the million-dollar engineering question, right? How do you build a motor that can spin at thousands of RPMs, generating all this crazy heat, without wrecking the very magnets that make the whole thing work in the first place?
Well, the answer is another special ingredient, a rare earth element called dysprosium. The best way to think about it is like a kind of high-tech sunscreen for the magnet. You add just a tiny pinch of it, and suddenly the magnet can handle intense temperatures. It keeps its strength through all those cycles of heating up and cooling down, which is what makes it reliable enough for a modern EV. So you have this super magnet, but it needs a secret ingredient to work inside an EV. And this is where the story pivots, taking us from the science lab straight into the world of global economics, and a story of almost unbelievable market dominance. Okay, so where on planet Earth do we get these finished, high-performance, heat-resistant magnets that are so vital for this whole green energy transition? The scale of this dependency is just staggering. Get this, in 2021, a full 75%, that's 3/4, of all the high-strength NdFeB magnets imported into the United States came from just one country, China. And that dominance isn't just about the finished product. Oh no. China controls huge chunks of every single step of the process, from mining the raw materials, to separating them into oxides, to producing the metals, and finally manufacturing a whopping 92% of the world's finished magnets. Look, this level of control is way beyond just having a big market share. When one country dominates an entire supply chain for something that's critical, it becomes a strategic dependency for every other country that needs it. And that has some major implications. In fact, this dependency has become so extreme that the U.S. government has officially looked into it as a potential threat to national security. The U.S. Department of Commerce actually launched a formal investigation. This is the kind of thing they reserve for figuring out if imports of a certain product are a direct threat to the country's security. And the conclusion from that official report, it was crystal clear. The current reliance on these imported magnets, quote, threatens to impair the national security. So why is it considered such a serious threat? Well, it really boils down to 3 key areas. First, defense systems. These magnets are totally irreplaceable in things like fighter jets and missile guidance systems. Second, critical infrastructure. They're essential for the EV motors and wind turbines that are at the heart of our green future. And finally, geopolitical leverage. China has actually restricted rare earth exports in the past to get what it wants, which makes this a very real vulnerability. This pretty stark reality has kicked off a massive effort. The new goal isn't just to compete. It's to build an entirely new, independent American supply chain, basically from scratch. This is the race to rebuild. The ambition here is huge, to create a complete mine-to-magnet supply chain right here in the United States. That means mastering every single step, from digging the rare earths out of the ground to processing them into super pure metals and alloys, and finally, manufacturing the finished, high-performance magnets.
And the clock is absolutely ticking. The timeline is really aggressive. We've already seen major investments announced, and construction is getting started on new facilities. The big target date everyone's looking at is 2026. That's when the first wave of these new American magnet factories is supposed to come online and start producing.
But let's be real, this is a massive uphill battle. For decades, China poured strategic government investments into building this dominance. So now American companies are facing higher costs trying to compete with a state-subsidized machine. There's also a serious shortage of skilled workers and huge hurdles in just getting access to the key intellectual property. And on top of all that, you have the challenge of breaking into a global supply chain where Chinese companies are already deeply, deeply entrenched.
So all of this sets the stage for a really fundamental question about the future of power. We're talking both the electrical power that moves our cars and the geopolitical power that shapes our world. And here's the really sobering part. Even under the most optimistic projections from the Commerce Department, these new U.S. factories could satisfy, at most, 51% of America's demand by 2026. That means that even if everything goes right, a significant dependency on imports is probably going to be here for years to come.
So what's the real takeaway here? It's this. The race to build a sustainable green energy economy has become completely tangled up with a geopolitical race to control the critical materials that make it all possible. You simply can't separate the two anymore.
Which leaves us with this final massive question. The transition to electric vehicles, to renewable energy, it's all accelerating faster than ever before. But in this global sprint to electrify everything, can a new, secure supply chain really be built from scratch fast enough to keep up and truly secure the future?